Hi, a boat takes 6 hours to go downstream in a river and it takes 24 hours to return the same distance. What is the time taken by the boat in still water? Let's first discuss the motion in downstream. Boat going downstream means the direction of boat motion is the same as direction of river flow. So river and boat, they both move in the same direction. Now the river is already flowing and on river the boat is traveling. So when we view boat from ground, we see boat traveling on flowing river. So total speed of the boat from ground is the speed of river flow plus speed of the boat on river or speed of the boat relative to river. And when boat is going upstream, it means river flow in one direction while boat travel in the opposite direction. In that case also, when we view boat from ground, we see river flowing in one direction and on that river the boat is traveling in the opposite direction. So speed of the boat is the combination of speed of river flow and speed of boat on the river. By speed of boat on the river, I mean speed of boat relative to river. Let's show this situation by a simple diagram. In this diagram, Vd represents speed of boat when it travel downstream. When it travel downstream, Vd is the speed that we measure from ground in relation to the ground. This V represents speed of river and Vu represents the speed of boat when it travel upstream. We must note that the speed of boat when it travel downstream is higher than the speed of boat when it travel upstream, when it is seen from the ground. Because when the boat is traveling in the same direction as river flow, the total speed of the boat as appearing from ground will be the sum of river flow speed plus the speed of boat on river. But when the boat is traveling in the opposite direction to river flow, river is flowing in one direction and boat traveling in the opposite direction, then the total speed of the boat that we see from the ground will be less. So Vd represent speed of the boat when it travel downstream and Vu represent the speed of the boat when it travel upstream, while we denote by V the speed of river relative to ground. When it travel downstream, the boat goes through the distance of d as I have shown here, and when it travel upstream it travel the same distance, because in the problem it is given that the boat is returning to the same point from where it started. So first it traveled a distance of d in the direction of river flow, and then it traveled in the opposite direction of river flow through the same distance so that it arrives back to its original spot as seen from the ground. So all measurements we are doing are relative to ground. Let's first discuss downstream motion. When it is a downstream motion, as I already told you, that if river is flowing in say this direction as shown by arrow, and the boat is also traveling in the same direction on river, then the total speed of the boat, this is the we represent the speed of river, and speed relative to river or speed of the boat relative to river or speed of the boat measured relative to river. We represent that speed of the boat relative to river by say Vd dash. Vd dash represent boat speed relative to river. So if you look at that boat from ground the boat speed Vd appears to be the sum of river flow plus speed of the boat relative to river, because river is already flowing and on the surface of river it is the boat traveling with this speed. The speed of the boat measured relative to river It's called relative speed, and we denote it by V dash D. So speed of river plus speed of boat relative to river will give us total speed of boat as seen from ground. So we write speed of boat when it is traveling downstream relative to ground is equal to river flow speed plus speed of boat relative to river or river flow. Now what's given in the problem? In the problem it is given that a boat takes 6 hours to go downstream. Means to travel the distance d, boat takes 6 hours when it is traveling in the direction of river flow. And this is the speed of boat as measured from ground. So we know that the speed of boat can be written as the distance it travelled divided by the time it takes, and time taken is 6 hours. So we write Vd equal to d by 6. We substitute for Vd as d by 6 in this first equation and write d divided by 6 equal to V plus V dash d. This is for downstream motion. We can write similar equations for upstream motion. Let's denote this equation as equation 1. Now upstream motion. In upstream motion, river flow say towards right with the speed denoted by V, and boat travel in the opposite direction. Boat travel with the speed say Vu dash relative to river flow. So total speed of the boat as seen from ground, we denote it by Vu, it is equal to again the speed of river plus speed of boat relative to river. So again we have an equation for the speed of boat relative to ground as Vu, the speed of boat relative to ground is equal to river speed plus speed of boat on the river or relative to river flow. And it's given in the problem that when boat travel upstream, it takes 24 hours to return to the same spot. So as the boat is returning to the same spot, it must travel the same distance in the opposite direction. The distance travel in the opposite direction will be denoted by minus d, because the distance towards right is denoted as d, so the opposite distance traveled will be denoted as minus d, and it is taking 24 hours to travel the same distance in the opposite direction when it travel upstream opposite to the river flow. So the speed of boat as measured from ground will be again the distance that it travel, which is minus d for upstream, divided by time taken, which is 24. So we replace Vu by minus d by 24 and we get an equation minus d by 24 equal to V plus V dash u. Let's denote this equation as equation 2. In this problem, we have to find what time will boat take if the water was still but not flowing. Now, the speed of boat relative to river is determined by engine power, is determined by engine of the boat. And if the engine of the boat is working with same power when the boat is traveling downstream or it is traveling upstream, if the engine is working with the same power in both the cases, then speed of the boat, its magnitude relative to river flow will be same. The boat will travel with the same speed in the direction of river and as well as in the opposite direction of river flow if its engine is working with the same power. We are assuming that the engine of the boat is working with the same power in both the cases, and the speed relative to river flow will be same in both the cases. Magnitude of the speed will remain same, but because the direction of the speed of a boat relative to river will be opposite when it is traveling downstream and when it is traveling upstream. So because the speed relative to river has opposite directions, the two speeds will differ by algebraic sign. We must understand, we should not confuse about algebraic sign. This problem is a good exercise in understanding the importance of keeping algebraic sign in our calculation. Algebraic sign might lead you to the wrong answer if you do not properly understand the meaning of algebraic sign and where they have to be applied. In mathematical calculation, we always try to reduce the number of unknowns. See, the speed of river flow which is denoted by V, it is present in both the equation and it is among unknown of the problem. We are not given the speed of river flow. So, we should try to eliminate V by using the two equations. And it can be readily seen that if we subtract equation 2 from equation 1, then we will disappear from the resulting equation. So let's do subtraction. From equation 1, we subtract equation 2 and this will give us minus equal to, we subtract left hand sides and right hand sides separately. On the left hand side, we get 5d by 24. V dash d and V dash u are speeds relative to river flow and they are also unknown. But everything about these relative speeds is not unknown. There is one thing that we know about relative speeds. V d dash is the relative speed with respect to river flow in downstream motion, while V dash u is the relative speed of the boat with respect to river flow in upstream motion. I told you that this relative speed of the boat depends upon engine power. It doesn't depend upon how fast river is flowing. However fast river may flow, the speed of boat on river or relative to river is determined by engine power, and we are assuming that the engine power is same in both the cases when the boat is traveling the direction of river flow, that is downstream, and when it is traveling in the opposite direction, which is upstream. So magnitudes of these two speeds are equal. However, they have opposite algebraic signs because V d dash is the speed relative to river in the direction of river, while this upstream speed is in the opposite direction of river flow. So they will have opposite signs. Speeds relative to river. Upstream relative speed is equal to downstream relative speed, but they have opposite algebraic signs. So we replace V dash u in this equation by minus V dash d. Let's call this equation as equation 3 and this as equation 4. So using equation 4 into equation 3, it gives us 5d by 24 equal to V dash d minus V dash d. This gives us 5d over 24 equal to, this is V dash d minus become plus, and we have 2 V dash d, and finally it gives us V dash d equal to 5d upon 48. We have found relative speed of boat in terms of the distance d. Now, if the river were not flowing and water was still, what time will the boat take to travel the same distance d? That is what we have to find. Now when river is not flowing, it will not contribute to the speed of boat as seen from ground. The speed of boat will now only be due to the engine power or the engine of the boat. River is not flowing, so it will not contribute to the speed of the boat. So speed of the boat is solely due to the boat engine. So now we talk about the case of still water. When it is still water, the speed of river is 0. Recall this equation for speed of boat from ground. For example, in downstream motion, the speed of boat relative to ground was the speed of river plus speed relative to river. But when water is still, the speed of river is 0. So we use this equation with the speed of river equal to 0 and rewrite it as the speed relative to ground equal to the speed relative to river in still water. It is still water. Now we have to find what time it will take to travel the same distance in still water. So Vd, which is the speed of boat, we can write it as distance divided by time taken. And this speed, the speed of the boat due to boat engine, we have already obtained it as 5d upon 48. So for Vd, for V dash d, we write 5d upon 48. Note that t is the time taken to travel the distance d when the river flow speed is 0, means water is it is a still water. Now d cancels from both sides and we get t equal to, which is the time taken to travel the distance d in still water. It is 48 by 5. We can write 48 as 45 plus 3 divided by 5, and it gives us the time t equal to 9 plus 3 by 5 hours. That is, t is equal to 9 hours plus 3 by 5 hours. Now we know that 1 hour is equal to 60 minutes. Then what minutes is 3 by 5 hours? We multiply both sides by 3 by 5. So on left hand side we will get 3 by 5 hour. On multiplying by 3 by 5, we also multiply on right hand side by the same number 3 by 5 and we get minutes. So we find that 3 by 5 hour is equal to 36 minutes. So finally, the time taken to travel the same distance, which is 9 hours plus 3 by 5 hours, we obtain that time as 9 hours and 36 minutes. Thank you for watching the video. Please like, share and subscribe.